If you were to work a job, let's say at Sonic, and let's say you made $9 an hour, how would you calculate your pay at the end of the week?
Times by how many hours you work?
Right, you take the hourly wage times the number of hours. So your pay times your hours equals your total for the week, right? Okay, so this is an example of a direct variation. This number's constant. Your hourly wage, your pay per hour, the $9 an hour. This number's right, but in general, this number stays constant, but these numbers could change from week to week, right?
Yeah.
You may potentially work a different number of hours. This one stays the same. You multiply them together. So as this one gets bigger, so does this, right?
Yeah.
So that's called a direct variation. When one goes up, so does the other one. This number always stays constant, all right? So that being said, let's look at this first problem.
Would you divide 45 by 361? Could that tell me why?
Well, first thing you do is set up an equation, but it's close to that, yes. It says, suppose that y varies directly as the square root of x. Well, on that last page I just showed you, we had your total pay vary directly as the hours you worked, right? Your pay at the end of the week varied directly with the hours that you work. So if y varies directly with the square root of x, here's my equation, y varies directly means you're going to have some constant value that you don't know that you're going to multiply by. And what am I multiplying by? I'm multiplying by the square root of x. So this is the equation I get out of that first sentence. Y varies directly. So here's my y. Varies directly means I have some constant that I don't know. And I'm multiplying because it's a direct variation. And what am I multiplying by? The square root of x. So this is my equation. Now all you have to do is plug in numbers, and you'll have to do it 2 times. The first set will find k for you. So it says that y is 45 when x is 361. So plug the numbers in. 45 when x is 361. So what's the square root of 361? You're going to need your graphing calculator out for this lesson, so make sure you've got it handy. Square root of, I believe it's, double check for me, but I think it's 19. Square root of 361.
Yep.
Okay, so if I want to know what k is going to be equal to 45 over 19. Now, granted, there's some decimal answer for this, but that is an intermediate answer. It's not our final answer. Our goal was not to figure out what k is equal to. So I'm going to rewrite this equation right here, but this time I'll replace the k with what the k, because the k stays constant. It changes no matter what x and y, or it stays the same no matter what x and y are. Just like in that last example I did, the $9 an hour stayed constant no matter how many hours you worked, right? So since I found k using these numbers, I know that will stay constant. So now that I have this equation, now I can plug in my last thing. It says, what is y when x is 196? So I'm going to replace x with 196. Y is going to be 45 divided by 19 times the square root of, what did I say, 196?
That's 13.
I think it's 14. Y is equal to 45 divided by 19 times 14.
6.
Okay, so on your calculator, you want to take 45 divided by 19, then times 14, and tell me what you get. I need somebody to confirm that.
33.16.
I need somebody to type it in and confirm it.
33.
45 divided by 19 times 14.
That's it.
No parentheses required. What do you get?
33.16.
So it said specifically
Wait,
to...
no, not 13.
Oh, round it to 1/6. Okay.
It's a 1/5. It's a 1/5
I
something.
got one.
Okay.
Makes it that, because they're round.
It says round your answer to 2 decimal places. Make sure you read the directions because they'll have you rounding to different places every time. Okay? So that's your answer, 33.16.
16.
33.16. Everybody okay with number 1?
Yes.
All right. Why did you change what?
Why did you change the y to equals 45 divided by 19? Why didn't you just keep the k?
Because I figured out what k was equal to.
Yeah.
So once I
So you
knew what
plug
k
the
was
K
equal
in.
to, I just plugged the k in.
Kinda looks
Yep.
like you put a G equals.
Yeah, that's what I was saying.
Yeah, it's a y, not a g, sorry.
Yeah,
Okay.
that got me all messed up.
Okay. All right.
Can I get you a drink now?
Y.
Oh,
Okay, example 2.
varies inversely as the square root of x.
No, it did not say the square root of x. Square of x. You threw the word root in there, right?
You forgot to put it in there.
No, I did not. Okay, now watch this. Watch this. It makes a difference. Listen.
So x squared.
Y is equal to.
K times x
Nope.
squared.
It doesn't say directly.
Inversely.
Last one said directly. This one says inversely.
over
Inversely means to divide instead of multiply. So when it says a direct variation, you multiply.
X squared.
When it says the inverse variation, you divide. So I'm going to divide by x squared, not the square root of x, but x squared. So there's my little formula.
I already don't like it. Now you're gonna try to find k, but you can't. You know why?
Why?
Because it's not.
I think I can do it. Okay, let's look and see what we've got to plug in here. It says my y is an 11 when x is, or my y is 3 when x is 11. So replace y with 3 and replace x with 11.
11 squared. What's that?
What is 11 squared?
121.
121. So now I've got 3 equals k over 121. How do I solve for k?
You do multiply by 121.
So 3 times 121 would be 363. So now I can go rewrite this equation, and this time I know what k is.
Yep.
K is 363 divided by
First
x
stuff.
squared. Okay?
Which is.
So Jesse, why did we divide on this one and we multiplied on this one? We multiplied here, we divided here. Why?
So you're gonna get y
Inversely.
Inversely, that's correct.
363 divided by 324.
Where'd you get a 324?
18
Ah,
squared.
x is an 18. So if I replace x with an 18, 363 divided by 18 squared, type it in the calculator and tell me what you get for y.
Is there Jillian that?
Tell me what you get for y.
December.
That's 12.
No Jillian in the middle of that. I would have.
Comes out to be 12?
No, I don't know.
363 divided by 18 squared.
It's like point. It's like 1 point.
1.12.
1.12?
Dude, I was pretty close.
Okay, we're rounding to 2 places because my directions did not specify there. It should have, but it didn't. 1.12. Everybody okay with that?
Yeah.
That would be my answer for y if x is an 18.
$1.12 sign.
I don't think there's any dollar signs.
But
You
count
don't need
on
any
it, put a dollar
units.
sign.
It's Hawk's learning system you need to worry about. Yes, they would. You can't put a dollar sign in there. Okay. Yep. I'd take -1 off from that.
What if we drew it really dark?
-1.
and erased it?
-1.
Not really there.
-1. Okay, number 3.
Right. Bone thing.
All right, so Hooke's law, which is a physics law, says that the force exerted by a spring in a spring scale varies directly with the distance that the spring is stretched. So we're going to stop right there at the first sentence. It's really important on these that you can pick out the important words, okay? So if you can pick out the subject and the verb, using a little English here, and throw out all the prepositional phrases, you'll probably be able to write the formula, okay? So force is actually your noun in this problem, okay? What is the force doing? It is
Springing.
varying directly. What is it varying directly with? The distance. Okay, so by the spring is a prepositional phrase. You remember prepositional phrases from English? Okay, when it's by the spring, or by the spring and in the spring are both prepositional phrases. So anytime those little tiny words like that, by, of, in, around, above, under, all those kinds of things are prepositions. And so prepositional phrases can be thrown out of the sentence and the sentence still makes sense. Okay? So we have a force varies directly with the distance. That's all I really need to write this formula. The force varies directly with the distance. So force, I'm going to use F for force, equals... This is a direct variation, so if it's a direct variation, I put my k at the constant that I don't know, times what? What is it varying directly with? The distance, so d for distance. Force varies directly with distance, kind of like our total pay varied directly with the number of hours
We're
worked.
gonna write Sirius is headed. We're gonna do
Okay.
instant formula and everything else.
No, you're not doing distance formula at all.
Better not have to.
Okay, so force is equal to constant times distance. Let's see what numbers they give me to plug in. They give me a 33-pound mass suspended on a spring scale, stretch the spring 11 inches. So when you look at the two numbers, the 33 and the 11, you should be able to figure out which one is the distance. Is 33 pounds represent a distance or 11 inches?
11.
Okay, 11 has inches on it, and that's the distance. So you're going to know that the 11 goes there. You may not be familiar with forces if you haven't done physics, but they are measured in pounds, and that's where the 33 goes. So then I'm able to solve for K. So if I solve for K, I get what?
3.
3.
Trace.
K is a 3. Does that make sense?
Yep.
Okay,
So then
So-
you use 40.
let's rewrite it again, letting that K be a 3. So in physics, that's called the spring constant. That number right there would be my spring constant. All right, now let's see, what else do they tell me in the end? How far will a 40-pound mass stretch the spring? Okay, well, if I have a 40-pound mass, that's a force. I want to know how far it will stretch the spring, so I'm looking for the distance.
15.
So that's going to be 40 divided by 3, which needs to be rounded to the nearest hundredth. What does it mean to round to the nearest hundredth? What does it mean to round to the nearest hundredth?
Oh my god.
Hundredth is how many decimal points?
2.
2.
It's really
So my distance,
2.67.
40 divided by 3, 13 point,
Oh, I did it wrong.
13.33.
You idiot.
I didn't read the 40.
40 divided by 3 is 13, because 13 times 3 is 39, so I knew it was 13 and a third.
Dang.
So the 3 repeats, so it's 13.33 if you round to the nearest hundredth. You don't want to miss a problem because you rounded to the wrong place.
For some reason, I was thinking 45, 15.
Yeah. You're
Yeah,
gonna,
okay.
Yep. You will.
Cover yourself.
All right. Everybody okay with number 3? Ready for number 4?
Yeah.
Here's your jerk face.
Okay, number 4. Okay, this time I've got a volume of gas in a container varying inversely with the pressure. So it's not too hard on this one to pick out the keywords. Volume of a gas is a prepositional phrase. In the container, a prepositional phrase. So volume
Dividing.
varies inversely as pressure. Okay?
Dividing.
Okay, so how do I write my equation? V for volume
Yep.
Yep.
equals what?
Something over something.
Equals
K.
K over some squared.
No, it doesn't say to square the pressure. It just says pressure. It doesn't say pressure squared.
So does P.
Right? So just P for pressure. Volume varies inversely as pressure. So that means that as my pressure goes up, my volume's going to go down. Or if my pressure goes down, my volume will go up. Okay? That's an inverse variation. It works a lot like the reciprocal function. All right, so I got a gas that has a volume of 226 cubic inches. So my volume is
226.
226 cubic inches, and my pressure is
7.
Nope.
Oh, no, we're doing 5.
5 pounds.
My bad.
So now I can solve for P. How would I solve that thing? Or not P, K.
It's okay.
How can I
Times
solve
it
for
by
K?
5.
Yeah, 226 times 5 is
You get
what?
1,400 and something.
1,400 and what? Type them in the
I
calculator.
was guessing.
5 times 100 plus 100
what was it?
plus 6. 226 times 5.
1130.
1130. Okay, 1130. Listen. Shh. So if I were doing this problem without a calculator, I would split the 226 into a 100, a 100, and a 6. Because I easily know all these, right? So that's 500 plus 6, which is?
30.
You know 5 times 2
Oh,
is
sorry.
Oh my God.
5 times 6 is 30. 500 plus 500 plus 30 is 1,000, and then 30. So 1,030.
Now it's 1130.
Same thing. 1130 is the time. 1,130.
11:30 a.m.
Okay? So K is 1,130. So now I can go back and I can replace my K with 1,130.
I told us not to say and when we're saying it.
Okay. Because the and means a decimal point. You are right on that officially. Okay? All right, so Now, what do I have left to plug in? What will happen if the pressure increases to 7? So in other words, figure out the volume if the pressure is 7. 1,130 divided by 7.
161.43.
Yep,
Anybody agree?
he is right.
All right, and you don't have to give the
Oh,
units,
tenth.
they'll be given for you, but if you were giving
No, it's
units, it would be in
nearest
cubic. Oh, nearest tenth,
Oh my God.
Nearest tenth.
161.4.
0.4. Okay. Is everybody okay with that?
Yep.
All right.
3 more examples to go. We're almost done.
Okay, example 5. All right, so this is a architectural engineering problem. Architectural engineering is about how you make buildings stand up.
No.
And this is a formula.
That's just a common knowledge.
This particular problem is about figuring out how much weight a beam can hold. Okay? You guys aren't old enough to remember when the middle school was born, or you were born before the middle school was built, after the middle school was built. But when the middle school was built, the PAC had to be torn down and rebuilt because it was not built correctly, and the engineer came in and looked at it, and he said, that roof will not even hold 4 inches of snow. You're going to have to tear it down and rebuild it. And they did. They had the complete exterior structure of the PAC done and had to tear it down and build it again. And there was a lawsuit over it, of course. The construction manager and the architect were blaming each other, and I don't even know whose fault it actually was in the end, but the point was, because somebody screwed up and didn't go by the engineer's recommendations, the roof wouldn't even hold 4 inches of snow, they said. So that's why these
Imagine that coming down.
yeah, so that's why these equations are important, okay? So, safe load. Let's pick out the keywords here. We got a safe load L, so that's going to be our noun. What is this safe load going to do? Of a wooden beam, all that's a prepositional phrase. It's going to vary how? The safe load is going to vary directly as the product of the width and the square of the height, and also inversely as the length. So that's going to be a crazy formula. So we've got our safe load L, and then it says varies directly. So that means I take K times something. What do I need to multiply the K times?
Something over something.
No, the product.
No, square root.
No, listen, guys, let's read.
The square of the height.
It varies
15.
Directly as the product of the width and the square of the height. Product means multiply, so I'm going to multiply the width and the square of the height. So the width times the square of the height. That's what I'm varying directly with. Varies directly as the product of the width
Inversely.
and the square of the height. And inversely is the length. Inversely means divide by, right?
Oh,
So lowercase l on the bottom for length. Capital L stands for safe load. Lowercase l stands for length. All right, so let's see what they give me. It says a wooden beam 5 inches wide, 7 inches high, and 240 inches long can hold a safe load of 4,580. So they pretty much gave me everything but K there. So my safe load is 4,580. Let's see, I got a beam that is 5 inches wide. So my W is a 5. 7 inches high, so my H is 7. And 240 inches long. So that's 240. So, how am I going to solve that then for K?
Times 240.
Times 240, then what?
Divide by 5.
Then
Divide by-
square root to 7.
You don't have to square root the 7 yet.
Yes, you do.
How about we
Such a big number.
multiply by 240,
Equals
and then we divide by
9,000.
5 times 7 squared.
That's more. Oh, geez.
Okay, so I took and multiplied both sides times 240. These are both multiplied times the K, so to undo multiplication, I divide by them, right? Now, when you type this in the calculator, you're going to want to make sure you have a parentheses here, because when you hit divide, It's going to divide by 5 and then take the final answer times 7 squared. You want it to do all this before it divides. If you want to put a parentheses here, you can, but you won't have to put one there. Okay, so type that in the calculator and tell me what you get for K.
Cool, I don't know if this is right.
It's a big number.
Like 4,000?
I believe it was something like that.
4,486.53. Someone might want to check me.
Okay, anybody else get that?
Same thing.
All right, so this is called an intermediate answer. It wants me to round my final answer. My final answer needs rounded to the nearest whole number, but because this is an intermediate answer, I'm going to give a few decimal points just to ensure that in the end I get it rounded to the correct place. So now I'm going to go back and I'm going to rewrite this formula. And instead of K,
Doing that one.
4, 4,
So find
8,
the K.
6. Yeah, the point in doing that part was to find the K.
Oh, now you have to take the
4486.53, that's times WH squared. Right, but remember the K value stays the same no matter what, just like in your pay problem, the $9 an hour stayed the same no matter how many hours you worked. It's the same concept. These are all problems where there's a constant.
But not every beam is 3 inches.
I know, but the constant is the same for them, just like in the spring problem, just like that's why it's a direct variation problem. So all of these variables can change. The length, the width, and the height can change, but the K value is constant. And that's probably got something to do with the type of material. Now this K value would change. This is probably, is this a steel beam, does it say? It's a wooden beam. So this is a wooden beam. So like, for example, my daughter Sydney is an architectural engineer. She has charts that would tell her the K value for the wooden beam. If it was a steel beam, she would have a different K value. It would all depend on what the material is made out of. So every material is going to have a different K value.
So we could have just called her an answer instead of working all that out.
Could have, yeah. All
She
right.
was talking about her kids.
So, all right. So, at this point, now I'm ready to plug in and figure out whatever it is I need to figure out. It says, what would a 3-inch wide, 8-inch high, and 168-inch long beam of the same material support? So they're asking me to find the load if I know the width, height,
3
and the length. Okay?
times 8 squared.
So my load is going to be 4486.53 times my, 3
Get a whole
Eight.
than the last one.
times 3 times
8,
8 squared, all divided by
1.
168. So in your calculator, nothing is required to be in a parentheses here because your calculator automatically works from the left to the right on multiplication and division. It's going to do the square first. If you do put a parentheses around it, it'll be fine, but you would not be required to there. So what kind of a load will this beam support? 30 pounds? That's it?
No.
That's not what I got.
That's what I got. I don't know.
I got-
5,000.
I got
got
5,127.46.
But.
But you're supposed to-
round to the nearest whole number.
Nearest whole number.
What an idiot.
So 5127?
Yep.
God, such an idiot.
5,127 pounds is what that beam can support. Okay, so when they put that beam up, they better not put more than 5,127 pounds of support of things above it, right? Because that's all it can support.
You really think
LBS.
that would even hold a person walking on the building?
You put like 4 domes on it if you get away.
All right, so here you got a outer space problem. You got a gravitational force between an object and the Earth is inversely proportional to the square of the distance from the object in the center of the Earth. So my force F varies inversely to the square of the distance. So my force
And the center of the
varies
Earth.
inversely with the distance from the object to the center of the Earth. So this just describes your distance so you understand what you're talking about.
Object and
Right, so here's the Earth, okay? So there's the Earth, and here's a satellite in outer space. So if you got a satellite in outer space, and I guess this would have to deal with an astronaut. So you got an astronaut out here in outer space. So the D is the distance the object is from the center of the Earth. So if your astronaut's out here, then D is this distance right here.
3,750 miles.
Well, it's 3,750 miles just from here to here, right? That's the center. Oh, no, the radius of the Earth is 4,000. Okay, so let me draw this a little bit bigger.
Okay, so the radius is 4,000 miles, so that's.
So from here to here is 4,000.
And then from there to the astronaut, it's 3,700.
Yeah.
Why'd you draw? Okay. So it'd be 7,750.
So this,
That's your total distance.
yes, that's correct. So that's your D.
Yeah.
So your astronauts out here. Now, if your astronauts is on the surface of the Earth,
It's only 4,000.
then it's only 4,000. But if your astronauts clear out here,
7,750.
right, 3,750. So you would put those two together to get the total distance. Okay, so first thing it tells me is on the surface of the Earth, he weighs 200 pounds. So if he weighs 200 pounds, that means my force is 200 when my distance is 4,000. Okay, when my distance is 4,000, his weight is 200. I could say weight here instead of force. All right, so I can multiply those two together. 2 times 4 is 8, and I have 3, 4, 5 zeros. So K is an 8 with 5 zeros. Right?
Little 800,000.
So now my formula looks like this. Force equals 800,000 divided by D. So now it tells me that the astronaut is out here 3,750 miles away from the Earth. So now my distance is 7,750. So
Equals 103.22.
I'm looking for the weight of this astronaut in outer space. Oops, I forgot to put my...
So it weighs 103 pounds.
So as you go into outer space, your weight changes because weight depends upon gravity. So my distance is 7,750. So divide those two, and what'd you get?
103.2.
And we're supposed to round to 1 decimal place, so 103.2 pounds. So on the surface of the Earth, the astronaut is 200 pounds. But in outer space, his weight, because gravity is decreasing as you go into space, which decreases your weight. Because weight is dependent
like
upon
water.
gravity. Okay, weight is dependent upon gravity. That's why when they go into outer space, they can float around because they become weightless eventually when there's no gravity.
You think,
Right?
you think the ratio, like weightlifts and gravity, is close to water?
As far as what?
Like weight?
Weight compared to the weight of water?
No.
How you? I don't get what you're asking me.
It's like if someone's sitting in water and someone's sitting